The James Webb Space Telescope has studied a lot of exoplanets at this point, mostly hot Jupiters and hot rocky planets, because those are the easiest to see. Of course, some of the planets people really want to hear about are the small ones, the ones in the habitable zones of their stars, like TRAPPIST-1, which James Webb has studied. Though so far, the results for the habitable zone planets have been inconclusive. And that's been true for a lot of the temperate exoplanets, except for a very small few. One of the planets in the habitable zone that actually had interesting results is LHS 1140b. In my opinion, the most interesting exoplanet James Webb has studied so far. LHS 1140b is a planet about 5.6 times the mass of Earth, 73% larger in radius, and orbiting on the outer edge of its star's habitable zone. It's only about a tenth the distance Earth is from the Sun to its own star, because its star is a red dwarf, about 18% the mass of the Sun. It takes about 24.7 days to orbit the star, and is the second of two planets, with the smaller one, LHS 1140c, on a much tighter 3-day orbit. Despite orbiting a red dwarf, LHS 1140b has been pretty much confirmed to have an atmosphere. This is because, despite what you may have heard, not all small planets around red dwarfs automatically become airless. For a more in-depth explanation of this, you can look into the concept of the cosmic shoreline and atmospheres of red dwarf planets. One of the likely reasons LHS 1140b has an atmosphere is because its star, LHS 1140, isn't very active as far as red dwarfs go, and is pretty calm. But anyway, given its mass and radius, LHS 1140b is most likely not a rocky planet, as its density is too low to be one. However, it is denser than many Neptunes and gas giants, suggesting its composition is somewhere in the middle of the two. This means it could potentially have a lot of carbonaceous or icy material, and even has the chance of being an ocean planet of some sort, with an ocean of water hundreds of miles deep, though this is currently only speculation and not actually confirmed. This is a pattern we've seen on many other similar planets before, such as the bigger K2-18b, which we know is probably a mini Neptune, though LHS 1140b is significantly denser than K2-18b, suggesting it has a very different composition and internal structure. Anyway, as already mentioned, LHS 1140b is in the habitable zone of its star, where temperatures are right for liquid water to exist. This puts this planet on the list of potentially habitable exoplanets. Usually, I'm very critical of this list, and there are many planets on it I think shouldn't be there. Not every planet in the habitable zone, smaller than a gas giant, has a real chance of being habitable. But LHS 1140b is one of the few planets that I do think actually deserves a spot on this list, for a reason that will become clear as we go on. Assuming no greenhouse effect, LHS 1140b has an estimated equilibrium temperature of 53 degrees Fahr, or 47 degrees Kelvin. Though, keep in mind, the planet's true temperature will certainly be much higher in real life, due to the presence of an atmosphere. For example, if it had a greenhouse effect as powerful as Earth's, that temperature would go up to about 19 degrees or 7 degrees. So anyway, one of the reasons I think this planet could be hypothetically, potentially habitable is because, despite what its composition may suggest, we have strong evidence that it's not a mini Neptune. James Webb observations have ruled out a thick, hydrogen-dominated atmosphere, like the ones many Neptunes and ice giants have. Again, look at K2-18b, which has evidence of a hydrogen-dominated atmosphere, and we can again see that LHS 1140b is not like the other mini Neptunes. If it does have a thick, extensive atmosphere, that means its low density must be the result of something else. such as an extremely deep ocean of water. If you've heard about ocean planets before, you'll know that there's some good evidence that many of our ocean planet candidates may actually be more likely to be soot planets, or planets made of a low-density carbonaceous material instead of water. Planets like these would have distinct characteristics, such as a high metallicity atmosphere and a high carbon-to-oxygen ratio in that atmosphere. So far, LHS 1140b has not shown signs of that. So, while an ocean is not confirmed, it does currently remain a possibility, especially when you take into account the other things James Webb has found on this planet. In 2024, James Webb ruled out the presence of a hydrogen-dominated atmosphere, which I've already mentioned. Those same observations also suggested that LHS 1140b has an atmosphere made of higher weight molecules, including water vapor, carbon dioxide, and nitrogen, with modest confidence. This is very important because if these molecules were to be confirmed to actually be present, the best explanation for them is that LHS 1140b is covered in a global water ocean. This is because models suggest that a water ocean is required to maintain a stable atmosphere of carbon and nitrogen, which these observations suggest LHS 1140b has. However, so far this was just based on models. For this to be confirmed, stronger evidence of these molecules was needed, and that's pretty much what happened. In July 2024, James Webb detected tentative signs of atmospheric nitrogen on this planet. While these observations have yet to be confirmed, combined with the previous paper, the case for at least nitrogen being present is pretty strong, just not yet confirmed. And this is extremely interesting. If confirmed, this would be the first observation of a secondary atmosphere around a potentially habitable exoplanet. Essentially, if a hydrogen atmosphere was detected, that would be an example of a primordial atmosphere, because when planets form, they tend to have hydrogen envelopes. For many planets that aren't gas giants, those hydrogen envelopes eventually fade away, leaving secondary atmospheres behind. Earth's atmosphere, for example, is secondary. And, as you probably know, it is composed of about 80% nitrogen. So, to be clear, if all of these observations turn out to be true, then LHS 1140b is definitely not a mini Neptune. However, it's also definitely not a purely rocky planet, leaving something in the middle as the strongest possibility. The best fit models for this planet suggest an atmosphere made of almost pure nitrogen, or, for some reason, really, really cold carbon dioxide. Though, just remember, this is all a tentative detection and not actually confirmed yet. More observations will be needed to confirm that LHS 1140b definitely does have a nitrogen-rich atmosphere. But if it does, what could that look like? And what would it mean for habitability? Well, assuming LHS 1140b does have a nitrogen-rich atmosphere, an ocean is very likely. But what that ocean looks like is another question, and there are several possibilities, depending on the temperature of the planet. First off, it's possible that LHS 1140b is a massive ice planet, with an underground ocean covered by a thick ice sheet. If this scenario is true, this planet could essentially be an extremely large version of the icy moons of the outer solar system, like a super Europa with an atmosphere, or a warmer version of Titan. This would be a pretty interesting environment. But also remember that LHS 1140b is most likely tidally locked to its star, giving it a permanent day side and a permanent night side. Taking into account tidal locking, as well as a higher greenhouse effect, it's possible that LHS 1140b could be an eyeball planet, a planet mostly covered in ice, but but with a huge circular sea of liquid water centered around the subsolar point. So, surface liquid water is not off the table for this planet. Basically, LHS 1140b being tidally locked would not make one side of the atmosphere scorching hot and the other side freezing cold. That's not how heat transfer works. Assuming the planet has an atmosphere, heat from the day side will be transferred to the night side. There will still be a significant temperature difference, but it may not be as extreme as what you're picturing. So, LHS 1140b could be an ice ball or an eyeball planet. Assuming the unconfirmed detection of a nitrogen-rich atmosphere is correct. Either scenario suggests an ocean is very likely, but those two scenarios have very different implications for the habitability of this planet. Unfortunately, because not much is known about this planet yet, a full analysis of its chances for life is not possible. So, this part is going to be more personal speculation, and you should take it with a grain of salt. For this, I'm going to assume the nitrogen-rich atmosphere scenario is correct, which, again, is not currently known to be true. How thick this atmosphere could be is unknown. But just having an atmosphere at all is good. Having an ocean is even more interesting, though. My thoughts about life forming on ocean planets are pretty clear, and I'll repeat them here. We don't currently know how life began on Earth, but most modern theories suggest volcanic activity was required in some way. This is fine for Earth, where there are plenty of volcanoes, hot springs, and hydrothermal vents for early life to take advantage of. But LHS 1140b may not have any of that. If it does have an ocean, it's likely much, much deeper than Earth's, maybe even hundreds of miles deep. Remember, LHS 1140b's density suggests it is not a rocky planet. It is very unlikely that hydrothermal vents could exist on an ocean floor like this, given how pressurized the water would be, and even more unlikely that life could survive down there. So, while LHS 1140b's environment may be, in theory, habitable, I'm much more hesitant about the idea that life could form there. Life isn't going to show up in every place with habitable conditions. A planet could be a perfect paradise in every way, but without the processes needed to get life started, it will remain dead. I wouldn't be surprised if LHS 1140b was an example of this, an incredibly interesting ocean and ice planet, but, unfortunately, with dead oceans. Of course, I could be wrong about this. Maybe there are ways for abiogenesis to happen without volcanic activity that we haven't discovered yet. I doubt panspermia would be very viable in this system, though, because there likely aren't any Earth-sized planets in the habitable zone, and the only other confirmed planet, LHS 1140c, is a hot, likely arid and barren super-Earth. So, in short, I think LHS 1140b probably has a decent chance of being habitable for some form of life. I can't say what that chance is, but I definitely think it's better than some of the crazy planets people try to parade as potentially habitable today. Even so, I still think LHS 1140b has a long way to go before we can truly consider it a strong candidate for habitability. I think it's unlikely that life exists here, but, unfortunately, we don't currently know, and we'll need a lot more observations to confirm any of this. Maybe this nitrogen-rich atmosphere explanation will be ruled out with more data, and this whole picture will age very poorly. Or maybe it will be confirmed, and we'll actually have the first definitive example of an ocean planet beyond the solar system. All in all, this is why I personally think LHS 1140b is the most interesting exoplanet James Webb has studied so far, and I can't wait to learn more about it. There's still a lot left to discover. I think this is our most likely candidate for an ocean world discovered so far, as well as one of the most likely candidates for an eyeball world. Probably not the most likely candidate for an ice planet, though, given the existence of TRAPPIST-1H. Hopefully, we find out more about it soon, because there are a lot of things about this planet that still need confirmation. Thank you for watching, and if this kind of topic interests you, keep exploring more about exoplanets and space exploration.